Question number 11 from a mock paper. A student is investigating this expression, and we need to expand each bracket binomially and multiply them to show this result. Okay, so the first thing we want to do is we want to spot that there's a fraction involved, which means we're going to be looking for sort of this version of the binomial expansion. Okay, because the one that has a 1 in it can handle these negatives and fractions and so on. The next thing we want to do is we want to rewrite this and say that it's the same as this result. Well, let's actually just change it to a bracket straight away, shall we? So it's the same as the square root to each of them, which means that it's the same as 1 plus x to the half. And then the other one is 1 minus x to the minus half. Okay, we're going to do the expansion on each of these. And I'm only going to go as far as the third term. So it's got something to do with this, and I'll talk about it a bit more when we get closer. So we only need to do the first three terms. So for the first one, which is 1 plus x to the half, the n value is a half. There is a 1 in the 1 position. The x part is just a positive x. So if I try subbing that into the result, I'm going to get the following. I'm going to get 1 plus a half of x plus 1 half, and then 1 less than a half is minus a half. 2 factorial is just a 2. And it's an x, so x squared will just be x. And if I tidy this up, well, I mean, it's just a tiny bit of tidying up, I suppose. 1 plus x over 2 plus an eighth x squared. Okay, so we're going to do the same now with the other result. And on the other result, n is minus a half, and there's a minus x. So those are two things that we need to look out for. So let's do that one now. And for this one, we're going to say, when we do 1 minus x to the minus a half, the n value is minus a half, and the x part is minus x. Okay, if you're wondering why I'm doing this x part here, we talked about this in a previous video, but it's just the way that this formula is written. It means the thing that is in the position of x here. So if we do this one, let's do this one in a different color. So we will get 1 plus a minus a half, a 1 plus minus a half, and then there's a minus x there. And then we will get, on this one, we will get a minus a half, and then 1 less than that is minus 3 over 2, and then this bit here is a minus x all squared. And this will turn into 1. This will be an x over 2, and then this bit here, 1, 2, 3. That negative is squared there, isn't it? So just a double negative. So I think that's going to stay positive then, isn't it? It's going to be 3 over 8 x squared. Now we need to multiply these together. So I'm going to multiply this result here by this result here. And the way I'm going to do it is I'm going to use a grid. I think it works very nicely with this particular type of question. So that's one of the results. And the other result is, what is it? 1, it's a positive x over 2. And it's a positive 3 over 8 x squared. Now, why did I say I only need the first three terms? So here's the idea. The number times a number, it gives us a number. A number times an x gives us an x. And we can think like this throughout the whole grid. And there are clearly some bits that we're not interested in. For example, x squared times x squared, x to the power of 4 is not required. So if you just do some thinking about the grid, you will find that we don't even need these three results here. Okay, so there's no point in us going to any higher powers. So 1 times 1 gives us a 1. This is a half x and a half x that together you can see are going to give us an x. And these three here will be the only different places where I could get an x squared from. So a 1 times an 8th x squared is an 8th x squared. This one over here is a quarter x squared. I'm going to write that as 2 over 8 x squared just for convenience. Okay. And then this one over here is going to be 3/8. So, I mean, that's going to be 3/8 over x squared, isn't it? Hang on, I'll just double check my work a second. Have I missed anything? We're happy with that. Minus an x, minus 1. Okay, so these are going to be my sort of different results that I get. And then the idea would be that I would add these all up together. So I would get 1 plus x. This was a show that, so let's use that to spot how we're getting on. So it says we should get 1 plus x, yes, and we should get a half x squared. So at the moment I don't seem to be getting a half x squared, so let's see if we can figure out why. So when I have 3 and 2, there's a 5, isn't there? So if I had 4 over 8, that would give me x squared. So what it is I've made a sign mistake there. So that's why I need to have clear work that I can check, and that's how we can use show that's, just to check how we're getting on. So that should be a minus, shouldn't it? Okay, so there we go. Making mistakes is a completely natural part. That's why we go back and we check our work. So we have 1, we have an x, and together these are going to give us 4 over 8 x squared, which is the same as x squared over 2. And we didn't go any further with the initial ones because we weren't interested in x cubes and so on. Now some smaller sort of questions to answer. So let's have a look at B. A student subs x equals 1 into both sides. What they mean on this one is that what they meant is they meant the original function, okay, and the expansion in order to approximate root 2. So why would this be not valid? Well, one thing that you might want to think about is when we see valid, we normally have this condition, don't we? Okay, that the value of what is in the x part needs to be, the magnitude needs to be less than or equal to 1. And you could see that that's one reason why there's a problem. It's not valid, okay? It's not valid as must be less, yeah? Must be less, not equal. So that's one reason, one justification, and that's the most common kind of one on this question. You talk about the validity condition. In your formula booklet, it's normally written after this, I think it is as well, okay? But the idea is the thing that is in the position of x must always be less than, the modulus of it must be less than 1. So that's normally the easiest answer. Another one you can actually see is if you substituted 1 in there, you would have an undefined fraction. Okay, so it seems like there's actually 2 answers for this one here. Okay, I think that's enough about that one though. So use your approximation with 2/3 to obtain a fractional estimate. Okay, this is quite a common type of question. So what you want to do is, first of all, you want to sub this in to f of x and see what it actually gives you, because it says root 5. It often doesn't give you root 5. You'll often get like root 5 over 7 or something. So don't just assume that it will actually give you the value that it says in the question. So we're going to do that first. So we're going to say square root of, what we're subbing in, 2/3. So that's 5 over 3 over 1 over 3. Right. So this time around, that actually does work. That is the same thing as root 5. But as I just said to you, most of the time that doesn't happen. Okay? Well, that's kind of like the left-hand side, if you like. What's the right-hand side to this? Well, that would be the expansion that we've just done before, which is, 1 plus x plus and so on. So the thing we would do over here is we would do 1 plus 2 over 3 plus a half 2 over 3 squared. Okay, and because the left-hand side actually does just turn into root 5, we would just say what that value is. Okay, so we're not working it out on our calculator. We're using our approximation from before to work that out. Is going to be the idea. So if I just quickly work that one out, I get 17 over 9. Okay, or 1.8 recurring. Okay, that one there I would say is probably a little bit different to how the question normally comes out in a test paper. So as I've said, I think this is in some of the other videos, part of the Countdown 90-day series. When you substitute the value in, you'll often find that you get this. So what you would do is, with your expansion, you would just sort of, multiply by 2 on both sides. Okay, and that's probably a more common question. But in this case, it turned out to be root 5 after all. Okay, so there we go. Question number 11, all about the binomial expansion.